My name is Bruno Oliveira, and I work with Android Developer Relations.
Hi, I'm Tom. I'm an engineer on the Google Play Services team.
And we're going to talk to you about some advanced games topics. Actually, we couldn't reveal that before, but our session is actually about advanced games topics using Google Play Game Services, of course. All right, so for this talk, we're going to assume that you went to the other talks and that you already know all the basics. Of course, I'm not talking about this basic. I'm talking about these basics. So you should be able to set up your game. You should be able to create a client ID. You should be able to write the sign-in flow, basic stuff like achievements, leaderboards, and then set up a multiplayer game as well. So we're not going to cover any of those basics. Now, we're going to talk about a few topics that go beyond a basic game. We're going to talk about some of the things that real games often need. So Games Client is great. I mean, I love it. And for simple games, it's all you will need. But for real games, often have a need to use Plus Client and App State Client as well, and manage all three of them in a way that makes sense. Now, real games have players that deeply care about their progress. So I pick up my game, and then I spend countless hours battling monsters, solving mazes, collecting loot. Eventually, my level 1000 fighter, wizard, cleric, bard can survive pretty much anything in the known universe, except a phone upgrade that kills him. So real games have players that deeply care about that kind of thing. Which is why real games need cloud save. Not just simple cloud save, but you need to deal with cloud save conflicts in a way that makes sense and doesn't lose any progress for your users. Also, real games often use native code, which, as we know, is pretty simple, right? And nothing ever goes wrong with that. Real games often need a lot more, like custom UIs. They need to do advanced auto matching. They need to integrate with third-party engines. So which is why we're going to structure this talk around 9 tips for real games. Actually, they're not exactly tips, because these are not things that you necessarily have to implement. Let's call them, say, information fauna. That's weird, right?
It's a little wordy. How about something simple like how-tos?
How-tos, yeah. How-tos better. So that's a good idea. So on to the first how-to, which is useful for games, and I think life in
Unfortunately, we can only teach you it for games, not for life in general. But
anyway, so what's that?
It's the universally accepted representation of a user.
Of course, naturally. Fortunately, I write code better than I draw pictures. So naturally, so some games manage to accomplish a very unique feat, which is to annoy the players right on the very first screen. That's actually pretty impressive. Like you show one screen and you can annoy most of the players. How does that happen? The one sure way to make sure that that's going to happen is if the player starts your game, doesn't even know what the game is about, and what they see is an annoying pop-up that might say something like that. Maybe not exactly with those words, but that's what they mean. You either sign into my game, or you get out of my game, because you have to sign in. So that's not a very good experience for the user, because maybe I don't even know what the game is about. A slightly less annoying variation is games that don't really require me to sign in, but then they spam me every time I start the game with a pop-up saying, asking me if I want to sign in or not. And then maybe I don't even know what the game is about yet, but then I keep getting spammed every time I start the game. So why should I click that if I don't know what the game is about? Compare that to this more friendly game experience that offers but doesn't force the option to sign in. Notice that it also explains to the user what it means to sign in the context of the game. And if I still don't feel like signing into the game, I can play single player, and that's still going to be fun. Now, I'm eventually convinced that I want to sign into this particular game, and then the game clarifies that I'm signed in and gives me an option to sign out. So I'm in control of the sign-in. And then it enables some additional functionality, like multiplayer, achievements, and high scores. So at the very least, any calls to the game's API in your code should be protected by that check. So if the game's client is connected, you call the method. If it's not, you do something else. But at least don't crash. And of course, if you want to implement that well-behaved sign-in flow, you need to make sure that you don't show a pop-up unless the user actually clicked the sign-in button, because it's very annoying to see a pop-up when you didn't ask for it. So to do this, it's important to keep in mind that calling connect won't actually show a pop-up. There's no pop-up if you call connect. So you can call that safely from onStart. Now, what the pop-up might show is when you try to resolve a connection result. This may show a pop-up. So you only want to do that if the user clicked the sign-in button. This is how you might implement this. You have a Boolean flag indicating whether or not the user has clicked the sign-in button. And then you use that flag to decide what to do with a connection failure. So when you get a connection failure, you see, did the user request sign in? If they did, then you can show then you can show that pop-up dialog. That's okay because they requested it. If they didn't, then you store that result for later. When the user eventually clicks the sign-in button, then you check if there's a pending connection result from the previous step. And if there is, you try to resolve it. And if not, you set that flag to true and then attempt to connect. And well, I think that's pretty much it if you only have Games Client. But Tom, what happens if they have something more complicated using, say, Games Client, Plus Client, App State Client? What happens in that case?
It's funny that you ask, because our next topic is exactly that.
Wow, what a coincidence.
What are the odds, right?
It's almost like we planned this.
Yeah, somehow. So we've talked in the basic talks about how you use a single Google Play Services client. But let's quickly recap what that looks like. You've got your onCreate method, then you have your onStart, where you connect to the Games client. If you get an onConnection failed, then you resolve your problems. OnConnected, you're ready to go. And then finally, an onStop, you disconnect. So if you've got multiple clients, when you get created, go ahead and create all the clients that you want, and then add them to an array so that you can keep track of them. Now you just start connecting your clients in order. Connecting an already connected client is totally safe. There's nothing else you need to worry about there, so you just don't need any extra error checking. If you encounter a failure while connecting, you just resolve it the way you normally would. Most of the time, that's going to involve launching some sort of intent to get a result back. And then once you get the result, you just continue connecting clients. If the client's already connected and you call connect on it, you'll get the onConnected callback. So in this callback, all you have to do is loop through it, looking for the first non-connected client, and then repeat the process. Once they're all connected, you're good to go. Finally, in onStop, all you have to do is disconnect all of your clients. That'll tear down all the state, make sure that everything's good, release all the resources. Different clients that you're going to be using ask for different permissions, right? Because they're accessing different user data. So if you just do the default thing we just showed you above, this is what your game's going to look like. You're going to see a sign-in button. The user clicks it. They'll see a pop-up. And then they'll see another pop-up. And then eventually they're going to make it to your game. That's going to make your users look like this, right? It's not a really good experience. So how do we do better than that? To avoid this, when you create your clients, you just request all of the scopes that you need all at once. So when you build every client, you just pass in all of the scopes that you want to use, and that's going to turn this nightmarish multi-pop-up scenario into this, right? It just consolidates them down into one, which will make your users look like this. So if you want some examples, you can look at our sample code. We've released this with the SDK. We have a games helper class and a base game activity class that use all three clients, games plus an app state, so that you can check it out and see how this works. So that's how you can use multiple clients. But now that the users are in your game, let's talk a little bit about actually giving them something fun to do. Bruno's going to talk about how to use the games APIs from, well, our favorite place, native code.
All right, so until now, we've been pretty much safely tucked inside the cozy virtual machine. But it's time to step out in that exciting world where many games live, and that's, of course, the world of native code. Nothing against Dalvik. I mean, virtual machines are just great, but when I first learned how to use native activity, I was really excited. It was like, yay, C, C++, and then I realized there was stuff that I needed to do in Java, too. Fortunately, there's JNI, which, as we know, is pretty simple and straightforward. So I call find class, and then I get my Java class, and everything should work, right?
Right, this always works.
Yeah, this always works. Yeah. And then, of course, I am met with sadness, because I see a class not found exception. And after digging a lot, that happens because that thing right there doesn't really have a clue about my classes. It knows about the framework classes, so if I'm trying to instantiate the framework class, that's fine, but my classes, it doesn't really know anything about them. There's a solution which involves getting a different class loader and so on, but here's a method that's often easier for native applications. If I derive my class from the framework's standard native activity, I can add some convenience methods to it, which I can then call from native code, without any need to deal with class loaders and any funny business like that. So I just load my shared library like this, as usual, and then I write a convenience method in my derived activity class, which I'll call from native code. In this example, this convenience method is calling GameSpy.submitScore, and then I'm going to call that from native code. How do I do that? Well, this is how I do it from native code. I just get the object, and then get the method using the method name and signature, and then call using call void method. So that calls my convenience method.
That just seems too easy, Bruno.
It's too easy, right?
Yeah.
So anyway, well, if you ever feel that anything looks too easy or too simple, just add a different thread into it. So as you know, multi-threading is very complicated. It is my opinion that if the world ends one day, it's going to be because of a race condition somewhere. So what about threading? So if native code often runs outside of the main thread, that's even the default if you're using a native activity. So what happens if you accidentally make a method call that should have been done on the UI thread from that separate thread? What's going to happen is that maybe your app is going to, maybe it's going to work. Okay, maybe it's going to work, and that's terrible because then you don't notice the bug. But maybe your app is going to behave in some bizarre, strange way. Maybe it's going to go up in flames and leaving only this mysterious error message behind. That, of course, is a very clear message, except that it's in log speak. And logs are very friendly creatures. They are, in fact, the developer's best friend. But they just have trouble expressing themselves sometimes. In log culture, this message really means, I really like you, but you're on the wrong thread. So if you see that message, that means there's nothing wrong. You're just calling that method from the wrong thread. And you should be careful to call that from the correct thread. In these cases, you can use the off-thread developer's best friend, which is?
Got to be their dog.
The dog?
Right?
Well, close. It's run on UI thread.
And this is why Bruno is a DevRel, not an artist.
Exactly. So summarizing, your native code calls your Java method via JNI. And then that method calls run on UI thread, specifying runnable. And when that runnable runs, of course, that's going to be on the UI thread. Then you finally invoke the Games API, and everything should work. So this is what your convenience method probably looks like. This method can be called from any thread, because it makes sure that this inner part only happens on the UI thread. You can even call it from the UI thread itself, because run on UI thread is safe to call from the UI thread itself. All right, so now that we talked about threads, let's talk about another interesting topic, which is the border. As you know, the border can be a very dangerous place. One hears lots of stories about the border. I'm, of course, talking about the border between Dalvik and native code. So there are many frightening stories about data structures that try to cross, don't quite make it to the other side. They fall prey to bands of stray pointers, and they wind up in the craziest places in memory. So, and there are stories of shipments that end up having to be copied every single time in what are very, very slow smuggling operations. And then there are even cases where things are so uncivilized around the border that the garbage collector has to do a lot of work to pick up the debris that your code leaves behind. So, which is why we're going to give you some quick travel tips to ensure that you have a safe and speedy journey down to the native border. First of all is travel light. Avoid copying tons of data back and forth across the border. Remember that copies can happen where you least expect. So for instance, even that code that looks innocent, you might actually be copying the whole 128K managed buffer twice in that code, maybe even 3 times. And that's all because you want to access 4 bytes out of it. Because when you call get byte array elements, you might be making a copy, and when you call release, you might be making another copy. A much more economical way to do that would be just to call get byte array region, and then just get the bytes that you need out of it. Also, pack the right buffers. That's very important. Remember that managed byte buffers are very fast to access on Dalvik, but maybe very slow in native code. On the other hand, if you're going to do most of your byte work in native code, then you should probably use allocate direct to get a direct buffer, because that's going to be fast on native, but maybe it's going to be slow on Dalvik. There's no solution that's fast and fast. You have to choose your buffers carefully, depending on where you're going to do most of the work. Also, don't engage in race conditions. You might have heard about race conditions. They are a dangerous local sport around the border, and they are not for tourists. So if you're sharing buffers, make sure between a native thread and native code, make sure you use the correct locking. Also, when you are, sometimes you can even call games client from different threads, but be careful not to call from 2 threads at any given time. So use some smart locking to make sure that that doesn't happen. All right, and last but not least, don't keep stuff that's not yours, that's frowned upon. I'm talking about Dalvik references, of course. So just because you got one through a method call, it doesn't mean you get to keep it. If you want to make a local reference global and keep it forever and ever, you need to ask JNI, and you need to ask JNI nicely. So what's the magic word?
Please, right?
Well, close to that. It's new global ref. So new global ref is the magic word that you use on JNI if you want to keep something that it has passed to you. All right, now that we talked about all this native code stuff that's pretty much down on the ground, let's take a break and go back to the sky. Let's talk about cloud safe. You know, like cloud, sky.
Cloud, sky, got it. Yeah, very clever, Bruno. So for those of you who were in some of the previous talks today, we talked a little bit about the cloud save features we're releasing. You could save your game in the cloud, load it again later on another device. It's pretty cool, right? But sometimes you have to deal with conflicts. This might happen if the user's playing on multiple devices, or if they play while they're offline and then come back online later. We're going to walk through how that works in a little more detail. As a quick refresher, if you're going to use the app state APIs, you have to make sure that your app is actually configured to use them. So you go to the Google API console and turn on the Google Play App State API bit as seen here. If you've already configured your game through the Play console to use the other games features, you're already set up. Everything's good to go. There are 3 main APIs that you'll want to use on the app state client. The first is load state. You call this to actually load the most recent state from the cloud onto your device. The next is update state. And you can call this to, well, update the state of your data. This form does a lazy update. It just schedules the update to happen whenever we next sync to the cloud. There's another form that you can call with an update state immediate that updates the state immediately. You might be sensing a pattern with some of these method names. Finally, there's resolve state. This is the API that you call when you actually want to resolve a conflict, and it's what we're going to focus on here. As you saw in the previous slide, whenever you actually load state, the first argument you pass in is an onState loaded listener. This is an interface that has two methods. The first is onState loaded, and that's what we call in the normal case where everything's working perfectly. The second callback is onState conflict, and that's what happens when our SDK detects that there's been a conflict somewhere in your data. It gives you back the data that's stored locally, as well as the data that's on the cloud. So to help illustrate what's actually going on here, we're going to talk about my favorite new game. It's this totally rad, totally awesome new game, and it's called Pick a Color. It's going to be the next #1 hit on the Play Store, I'm sure of it.
Awesome game.
So when we talked in the introduction talk, we mentioned that each write to the server is associated with a version. The way we deal with detecting conflicts is to separate our storage on the device into two areas. We have one for the local state and one for the latest we know from the server. We also maintain a dirty bit to help indicate whether or not the local data has been modified. So let's walk through what happens if I'm actually playing Pick a Color. I pick blue as my favorite color, and that writes locally that my data is blue, and then marks it as dirty. Now we're going to sync, send that up to the server, and that associates a new version from the server of ABC. When that returns to the device and says, hey, success, it's going to mark that the data is no longer dirty and store ABC as the current version. Now if I choose yellow, I'm going to write locally that the data is yellow and mark it as dirty. So what's going to happen if my device goes offline now? Well, it still knows about the data that I'm holding, still has all that state locally, and so the next time it comes online, it's going to try to sync. But what's going to happen? Let's imagine that we've got someone who else has got a separate device and has randomly chosen their favorite color to be green. I'm going to come back online, and now I don't know what's going to happen, right? There's going to be something weird here. So when I actually call load state, I'm going to get called back into Pick a Color with the onState conflict callback. We'll have local data as yellow, server data as green, and the version that it returns to us is the latest from the server, which is the EF in this case. So how can Pick a Color actually resolve this conflict? You've got colors, right? They don't merge very well. So maybe it's just going to ask me to pick my new favorite color. I'm a typical user, and of course that means I'm always consistent. So now I've changed my mind, and red is my new favorite color. So it's going to call resolve state with data red and version DEF, which updates the local data in the version. We send that to the server. The server now has a new version in the cloud, and when it calls us back with success, we mark that the data is no longer dirty and update our records. There we go. The conflict's resolved. So the resolve state API takes in new data that you want to pass up to the server. You're supposed to pass the best data for your users. But how do you know what the best data is, right? That's going to depend on your game. You could just take the most recent from the server, maybe newest is best, or you could prompt the user, kind of like Pick a Color did. But in general, you're going to want to do something a little bit better than that. If you store some data in your state, you could actually do a smart merge and figure out how to actually get the user into the best possible state. Let's take a look from another sample game. This is our other favorite game.
It's even better than Pick a Color.
I don't know about that. It exists, so maybe it's better. But this is one of the sample games that we actually released with the platform. You can see it's a really very exciting game. It's got a bunch of worlds, a bunch of levels, lots of deep, engaging gameplay. And to play this game, it's really, really hard. But you basically click on a level, and it asks you how many stars you got, and then it gives you that many stars, right? It's really hard. This is what our saved state for that game looks like. It's really just a map that says how many stars I got on each level. So if I have a conflict between this state on the left and this state on the right, which one of them is best? Well, we don't really know, right? I got different numbers of stars on a different subset of levels in each one. It was really hard to get all those stars, right? It took me a lot of hard work and a lot of pain, so I really don't want to lose those. So the right way to do this would be for a game to build a combined map that actually takes in the keys from both, and then in the case of collision between the keys, takes the highest value, right? Pretty simple. On each level, give me the best number of stars that I possibly got. The overall takeaway here, you have to figure out the right thing to do for your game in order to avoid losing progress for your users. So hopefully that gives you a little bit of insight into how we handle conflicts in the SDK, what kinds of things you should do with your game to actually handle this. Most of the examples games we used here are pretty basic. I mean, Pick a Color and collect all the stars are awesome, right? But they're not the most state-of-the-art games ever. Bruno, do you have any advice for people who actually want to make fancier, more exciting, more graphically intense games?
Sure. I know that after collect all the stars and Pick a Color, that sets the bar pretty high for games. But even though it sets the bar pretty high, you can still make good games after that.
You can do better.
Yeah, you can do better. All right, so let's talk about third-party engines. Now, there are exceptions, of course, but most non-trivial games are probably going to want to use an engine of some sort. You've been down this road before. We're all developers. You start thinking, well, engines are for lazy people, right? And then, man, this shader stuff is actually kind of hard. And then, wait, we can actually make it work if we just render everything backwards 3 times and then flip the y-axis. And that doesn't work, and then, we're never going to ship this thing. OK, let's use an engine. So you've been down this road before. So there are 2 kinds of engines, the ones that you have control of, and then you can call them from your code, and this other type that works in the reverse order. In this case, you don't call the engine. The engine is going to call you. The first type is trivial because it's no different from integrating with any other application. So we're going to focus on the second kind, which can be more challenging. So first thing you have to figure out in your engine is where it's hiding Android manifest.xml. It's definitely hiding that somewhere, because if it produces an Android APK, it has to hide that somewhere. So there should be an easy way to override it or add extra stuff into it.
If there isn't, it's seriously time to find a new engine.
Exactly.
That's kind of important.
Because if you can override an Android manifest, there's a whole bunch of things you can do. So once you figure out where your engine is hiding that, then you have to add some things into it. Particularly, you have to make sure that the game's metadata tag is there. And of course, if you use Cloud Save, you have to also make sure that the Cloud Save metadata is also there, which looks just like that one, except it says app state. Also remember that this is a resource reference, so you also have to add that resource somehow in the engine. That's usually done through an XML file. Now, you usually have 2 parts, which is the platform-independent code, which might be some game scripting language, and then you have the platform-dependent code. So you have to figure out where to put the platform-dependent code in your engine. So that's going to vary from engine to engine. But usually when we're talking about the Android platform, that typically means just dropping a jar file somewhere in the engine. And then there's going to be a way through which you can access the jar from your platform-independent code. Some engines have easy integrations with Java. If it doesn't, then you may have to resort to JNI. But in either way, you can access your jar file. OK, now it's time to set up your activity. If you can directly subclass base game activity, that's the best case scenario, because base game activity implements the whole sign-in cycle for you. If you can't do that, we're going to talk about next. But base game activity is available on the samples package. Now, if you can't, for some reason, subclass base game activity, don't worry, not all is lost, because you can still use games helper. Actually, base game activity is a pretty lazy class, because it's just really a wrapper around game helper. So if you can't use base game activity, you can still use game helper, which actually does most of the work. Base game activity just takes the credit for it. Now, specifically, you have to hook up on start, on stop, and on activity results on your activities lifecycle into games helper. Then you have to call on user-initiated sign-in whenever the user clicks the sign-in button. Of course, the sign-in button is up to you to implement. So it might be a rotating, floating 3D sign-in button when the user, or even 4D. When the user clicks that, you call on user-initiated sign-in to begin the sign-in process. And then you have to listen for the sign-in callbacks, which notify you when the sign-in has succeeded or failed. So usually hooking up on start and on stop are not really a problem, because most engines have good equivalents for that. Because those are pretty common lifecycle methods. Now, you might have a problem with on activity result. That can be more troublesome. Because if your engine doesn't give you access to that, well, then there's really only one thing that you left to do, which is you have to override your engine's base activity, and then update your Android manifest to reflect that. So you find out what your engine's base activity is, then override, make your own activity based on that, and then override on activity result. Also, remember that when what we mentioned about threads before. If you're sure that your engine always calls everything on the UI thread, that's no problem. Don't worry about anything. If you're using any thread that's different from the UI thread, remember to use the off-thread developer's best friend, which is, of course, run on UI thread, just to be safe. Summarizing, whenever the Games API wants to talk to your code, it's going to invoke your platform-dependent code, which includes the game helper, and then your game logic is going to be notified through the listeners that you installed on game helper. If you go the other way, then suppose you want to call the Games API, then you call your platform-dependent code, and then you post it runnable to the UI thread, and then on the UI thread, that's all on your platform-dependent code, of course. Then that runnable is going to call game helper, and then game helper is going to make the Games API call. Now, I know that this looks complicated, but it actually looks more complicated than it actually is. And to show you that this is not just theory, we've actually made a demo implementation and integration, and we published that at that URL. So that's already live, so feel free to download that and take a look at that game. All right, so now your immersive, nightmarish 3D zombie game is all fully integrated with our API. Now, since you're putting all this work to make sure that you have this awesome immersive experience, you probably want to make sure that you don't break that atmosphere by showing screens that have nothing to do with zombies at all. So how do you do that?
Well, we provided a lot of really cool UI widgets in our SDK for you, but sometimes those aren't right for your game. Sometimes they don't have the right style, they don't have the right theme, right? They don't really look right. It's OK. We're not going to be offended if you don't like our UI style. Well, much, maybe a little. But you can actually write your own custom UIs. So this is Nostalgic Racer. It's a little sample game that Bruno wrote to test out some of our platform. Wait, actually, hang on. It says right here that I'm supposed to wait for the audience to ooh and ah. Audience? Ooh. Ah. There we go. All right, cool. Only a little bit of prompting for that one.
It has square wheels, which is actually how physics used to work in the 80s.
Right. Like square wheels, pixels, giant pixels everywhere. It's really cool, really retro. But here's the problem. Here's our standard leaderboard UI, right? It's slick, it's high res, but Nostalgic Racer isn't really either
of those things.
Right. It doesn't really fit. So instead, we wrote a little custom widget here that's, well, more nostalgic, right? Keeps the users in that vibe, keeps it all going. So in order to let you build these experiences, we made sure that we had a raw data API for all of our features: achievements, leaderboards, players, invitations, et cetera. It was a really important design principle for us when we were building all of our widgets that anything we wanted had to be built on APIs that were available as part of the SDK. Otherwise, we're kind of cheating, right? And that's not cool. So how do you use these APIs? Here's an example using our leaderboard APIs. And there's obviously a lot more documentation available online. But in this case, you create a listener. Then you call one of our score loading methods. This one in particular is asking for the window of scores around the current player on the all-time social leaderboard, so the best scores from your friends. Once the scores are loaded, you'll get the on leaderboard scores loaded callback, and that'll give you back the actual data that you want. The status code here tells you what happened during the load, so if it's OK, it means you got new data, everything's great. If it's something else, you'll read the documentation and see what to do in that case. And then you actually get the actual data for your scores. Our API provides data in the form of data buffers, which are kind of like lists. You iterate through them and grab the data you want and bind it to your views. So that's great. It lets you put together all these awesome lists of data, right? But just remember that leaderboards don't have to be boring, right? Just because we're giving you an API that looks like a list of scores and names and numbers, that's not what you have to build. You can build something really cool. As an example of this, you saw this during the keynote. But this was a really cool integration from our friends at 2D Boy for their game World of Goo. The clouds represent your friends, and then you can kind of see your own cloud moving around as you up and down your tower, right? It shows you the scores, but it shows you them in an in-game, really interesting, really fun way. So we're really excited to see what kind of stuff you guys can do with this, and what kind of cool games we're going to get out of this. We've talked a little bit about building custom UIs, but let's switch gears a little bit here and talk about some of our actual UI widgets.
All right, so who likes to wait for stuff?
I do. Right. Totally.
Waiting is awesome. So when you start a multiplayer game, you have to wait for your friends to join. I mean, that's just life, right?
I don't know. I don't think people are actually that happy when they're waiting, unless they're me.
Yeah, that's true. Pretty soon, the users are going to be like that if they're waiting. And then they're going to go like that, and nobody wants that. So how can you make that better?
I mean, besides faster friends?
Yeah, besides getting faster friends and unfriending the slow ones. But that too. But even if you can't get faster friends, you should at least show a waiting screen that's not that boring. How do you do that? So for instance, with something like this. This is our built-in waiting room UI that you get for free with our API. So it actually gives me a sense of progress as I'm waiting for the game. It shows me which participants have joined, which ones are invited, and so on and so forth. So I have a general sense of the progress as the connection happens. So to launch it, all you have to do is first of all, you have to decide what's the minimum number of players that you need to start the game in a way that makes sense. And in this simple example, we're just using int max because this means everybody. We want to wait for everybody to join to start the game. And then what I do is I get a get real-time waiting room intent from the games client, and then I launch that intent. And notice that I should do that both from on-room created and on-room joined, because those are the two ways in which you can find yourself in a room. You either create a room, or you are joining a room that already exists. So on those two callbacks, you create the waiting room just like that. Now, eventually, the waiting room is going to get dismissed. And when that happens, that's going to happen for one of three reasons. First of all is if you get activity result OK, this means that the waiting room was dismissed because the game can start. This happens when everybody's connected, and you can start right away. If the user specifically asks to leave the room from the waiting room UI, you're going to get result left room. In this case, you should leave the room. Remember that the waiting room UI is nothing but that. It's a UI. So it doesn't actually leave the room for you. You actually have to write the code that leaves the room there, which is just one line. And then, of course, what might have happened is that the user dismissed the waiting room pressing the back button or the up button. In this case, the actual meaning of that is pretty much up to your game. You might want to make that the same as leaving the room, or you might just want to minimize the waiting room UI and keep that going in the background, however you wish. So that's going to depend on your game. Now, it's important to realize that when you're showing the waiting room, if you don't specify int max, and you specify an actual number of players that the game can start with, say, for example, 2, then, and if that is smaller than the number of players that are actually playing, what may happen is that the players may hit a button that's called Start Early. So whenever you have that number of participants, the Start Early button is going to be enabled on the UI. In that case, be aware that not everybody is going to hit that button at the same time. So if I have 4 players, and then I have 2 players who are, suppose that I invited 4 players, then I have 3. So it's more than enough to start the game because the minimum is 2, and then one of them clicks the Start Early button. The other ones are not going to realize that unless you implement that. So it's very important that you send a real-time message to the other participants saying, hey, we're starting the game. And then when you get the real-time message that we are starting early, you finish the waiting room, you dismiss it from the screen, and then start the game. Now, after the waiting room goes away, the game starts. Yay. So, but wait a second, that's not the game that I signed up for. I wanted to play a cooperative game, and suddenly, I'm surprised that everyone's killing everybody. So what's happening? I think I just got auto-matched into the wrong type of game. So, Tom, how can I stop that from happening?
Well, fortunately, we thought about this a little when we were building this SDK. We gave you this concept called a match variant. So what's a variant? It's just a number that helps identify what particular type of game you want to play. If your game supports multiple game modes, you're probably going to want to use something like variants. The contract with variants is that when we assemble the matches on the server, only participants who request the same variant will be matched together. That way, the people who want to play capture the flag aren't super surprised when everybody starts running around playing deathmatch and shooting them in the face, right? That's not a good experience for your users. How do you actually use these? Well, first thing you do is you declare a constant. A variant can be any integer between 1 and 1023. We figured we wanted to give you a reasonable number of them. When the user wants to start a new auto-match game, you just create a room config with the appropriate variant and create a room. There you go. So this is a user that's going to go into the auto-match queue for a deathmatch game. In general, you use the variants to split your players into separate pools so that you can match them only within their pool. This is great. You can divide your users into as many as you want, but don't go totally crazy, right? Different variants can't match together, so the more variants you use, the smaller the pool of players that can match in each pool is going to be.
That's also good advice for games and for life.
So if you have, 1 million users and you use 1 million different variants, well, then each user's off waiting in their own individual pool, and they're never going to find anyone to play with, and that's not fun. Sometimes you're going to need to make changes to your game that aren't compatible with previous versions. This is another way that you can use variants to help protect yourself from that. If version 2 of your game doesn't know how to talk to version 1 of your game, users of these 2 versions are going to see something that looks like this. So I'm in the game, I push, quick match, then I see please wait.
Or our waiting room UI, of course.
Even better. Oh, cool, someone joined. Now I'm getting ready to play the game. All right, get ready. This is going to be so awesome. Oh my God, this game's going to be rocking. Oh, whoops. Right, not really a great experience. So the long and short here is if you can be backwards compatible, obviously you should be. Sometimes you can't, so you just use variants. If version 1 and version 2 use different variants, then users won't get auto-matched together and get that bad incompatible experience. We're near the end of our time here. You guys are well on your way to becoming masters of using this API, but we've got one more thing to talk about, and it's every multiplayer developer's favorite topic. Let's talk a little bit about sockets.
All right, last one, sockets. Yay, sockets. Who likes sockets? So, as you know, I don't think I have to tell anyone what sockets are. You just push things on one side, they come out on the other side, that's it. So if they are reliable sockets, there's a guarantee that that's going to happen. But that's not how our sockets work. Our sockets are a form of unreliable messaging. It's like a UDP socket. So this means that you push things on one side, and on the other side, they might be missing, or they may arrive in a different order. So this is how our sockets work. So why would you want to use sockets? So for 3 main reasons. First of all, you might want to you might be trying to reuse some existing code or an engine that relies on sockets. You might decide that your game logic makes more sense if you have stream-like objects where you can push bytes on one side and pull bytes on the other side. Or maybe you're just sending and receiving a lot of stuff from native code, and you don't want to incur that cost of a dovec call every time you want to send a packet. So you just have a native file descriptor to use for that. So to enable sockets, all you have to do is call this during room setup. So remember, room config is how you configure the room. You just enable socket communications based on your room config, and that's going to enable sockets. Also, if you enable sockets, you can't use the high-level, unreliable real-time messages. You have to choose either one or the other. Can have both. So to get a real-time socket for a participant, you call, guess what? So it's another one of those intuitive API names, which is get real-time socket for participant. That gives you a real-time socket for that particular participant. And then you can get the input stream and output stream from that as well. And from that point on, it's just a regular input stream and output stream. You can push bytes on one side and pull bytes on the other side. Now, of course, sockets are a format of unreliable communication, so it's very important to understand how packets may be lost on the stream. So if I write lorem and then I write ipsum on one side of the socket, you might just get lorem ipsum on the other side if you're lucky. Maybe you're just going to get lorem. Maybe you're going to get ipsum. Maybe if you're on a particularly unlucky day, you're going to get zip, nothing at all. And then remember, you might also get ipsum lorem because the ordering is not guaranteed. It usually arrives in order, but it's not guaranteed. However, what we do guarantee that you will not get is a truncated packet, and we do guarantee that you're not going to get a corrupted packet, because we do guarantee that if the packet arrives on the other side, it's going to be exactly as it was sent. Also remember that there are no built-in delimiters, so you're going to have to figure out a way to tell when your packets begin and end, or either just put a special character or a length field or something else, because if you write ABCD and then EFGH on one side, you're going to get the string on the other side, and you're going to have to tell where they begin and end. And if you want to access the socket, the socket from native code, it's actually very easy to get a native file descriptor from that. You just call get parcel file descriptor, and then you call get FD, and that gives you a perfectly good integer file descriptor to use from native code. So I'm calling my native method, and of course, like any reasonable person, once I get a file descriptor, I write the digits of pi into it. So this is just native code. That write is just a standard, plain vanilla write system call that I'm calling with that file descriptor to write bytes into it. All right, so it's been, well, we've talked about a whole bunch of things. So from friendly sign-in, we talked about cloud save. We talked about a whole bunch of multiplayer topics, actually. We talked about how to integrate with game engines. We even talked about the exciting world of sockets and match variants. So we hope that these small bits of information are going to help you refine your game and make sure that it provides the best possible user experience. The reason I hope for that is because players nowadays are very, very demanding. And your quality control can't be just like that. Actually, we've seen worse. Some quality control is kind of like that. Anyway, that doesn't really work for games. Games have to be really, really awesome because there's a lot of competition out there for the user's attention. So unless your game is awesome, it doesn't stand a chance. So what we hope to do with the Google Play Game Services API is that we want to take the boring stuff out of the way. We want to take care of all that boring auto-matching and message transport stuff so that you can focus on what makes your game really, really awesome. So thank you very much for coming to our talk. And remember to rate our session. If you want to praise us or throw your virtual tomatoes, you can rate the session using either the QR code or the Google I/O app. So thank you very much.